Welcome back to a special Taproot TV episode. We're going to be kind of walking through a classic webinar in the Taproot repertoire, and I know today we're going to be getting beyond.
This is
Swiss
almost
cheese.
A blast from the past.
It is almost a blast from the past, and it's getting beyond Swiss cheese and accident investigations, modeling and improving human performance. So we're going to be covering a lot of different topics, kind of from the history of Taproot in this. So I think people are really going to enjoy this webinar. So kind of the start of this is really thinking about what are the causes of human error. So in your experience,
and why do you want to prevent it?
Yeah, why do people care about?
Because you don't want a Chernobyl, and somebody saying, "Oh, we can just run this test a little longer." You don't want a Texas City, where the guy was like, "Oh, I got to fill this thing up." You don't want a Deepwater Horizon, that's for sure. How many billions of dollars did that cost? So you don't want these things. You don't want people to make mistakes. The last mistake there was the guy didn't recognize a kick was happening until the mud and stuff started flowing out on the drill floor. And by the time that happened, it was too late to stop it because there was all that gas above the riser.
So people have been wanting to know that answer to what are the causes of human error, because we really don't want these accidents to happen.
Or how do you stop human errors?
And how do you stop it? So this has led a lot of people to really think about this problem and come up with ideas of how do you think about human error.
And there are lots of different models of human performance or human error. I mean, these are just a few of them here. It really is a case of what are these models for? What are we going to use them for? And one of the classics, of course, is the Swiss cheese model.
Yeah, Swiss cheese. Now, when we're looking for models, what are the things we need to consider when we're thinking about what model to choose?
Well, one thing is where did it come from and what's its purpose and what's it based on? So you've got, some models are made for PhD research. Some models are made to explain something to management or explain something to workers. So there's different purposes behind different models.
And is there something that would stand out in a purpose that you think is, not most useful, but what do you look for in a model?
Okay, if you were trying to understand human error and solve human error, that's a different model than maybe a cognitive psychologist sitting around talking with his buddies out having a beer at the college pub to discuss human error.
Now, I would assume most of the people watching this are more not on the psychologist. Maybe they're at a pub, but not the psychologist at a pub.
I don't know. Do we get our stuff get watched at pubs very often? I don't think so.
Now, Reason's model, what was its purpose?
So Reason is a PhD researcher, right? And he was a cognitive psychologist kind of guy. And his was to explain to either his views to other cognitive psychologists or his views to other people, which turned out to be the nuclear industry to start with, of what causes human errors, what are the causes, and therefore when you start thinking of what are the causes, you then start thinking of, well, how do you solve or how do you prevent or how do you understand human errors? And so there was a second part to the model, and that's in the bottom right side there, that slide, and that is the good old hazard and target model with what he called active errors and latent conditions.
So let's kind of walk in through, and this is your interpretation of the model, but walk us through that model.
Reason's written several books about this, and the model changes from book to book. It evolves. So this is I'd say, probably the most famous one of those. And a hazard is something, this is where you can get into big arguments, people, but a hazard in the old DOE model is a form of energy. And the target where this says accident is a person or the environment or the equipment or whatever. Reason didn't take it exactly that way. So his hazard and accident is sort of like this is the sequence of events. But it's not really a sequence of events. He has the reasons for the thing progressing from one stage to another is fallible decisions, line management deficiencies, psychological precursors to an unsafe act. The unsafe act itself and then local checks on adequacies of existing defenses. And the whole idea behind the Swiss cheese is if there's a hole in one of these slices of cheese, the hazard can progress along to cause an accident. And when all the holes line up, the hazard goes right on through and causes an accident. So it's not like this is PhD rocket science. This is a pretty simple model.
Yeah. Now, he expanded on this model and added the kind of the layers to it with others, and this was where kind of these active errors and latent conditions.
Well, this was sort of his root cause analysis, and he had slips, lapses, and mistakes, and then the next level down is latent errors. And a slip is you're trying to do the right thing, but you just goof up, you slip. Oh, hey. And a lapse is I was trying to do the right thing, but I just forgot. I forgot to do it. I don't know why I didn't do it. It was a memory error. And then mistakes are, I'm trying to do the right thing, but I grabbed the wrong switch and turned it. It was the wrong switch. I just made a mistake. And so there's his slips, lapses, and mistakes. And why he organizes them that way is beyond me, but it's just a model he came up with. And then he said, there's something beyond this. There's like a whole nother level. And that whole nother level is these latent errors. And there's system problems that sort of set up those next level of errors. So if the system problems don't happen, then you don't get a chance to make a slip, a lapse, or a mistake. And so there's these latent errors that are waiting to trap you. They're going to get you. And they're always there, but you don't normally see them because you don't have a slip, a lapse, or mistake that occurs.
So essentially you've got these different error types and latent conditions.
Yep.
And if we can identify and categorize these, we can then think about ways of solving these. Is that kind of what his end result
Well,
was?
I don't know about the thinking about ways to solving them. It's just a way to model human error. It wasn't really based on coming up with solutions.
Yeah, so Swiss cheese didn't really lead you to solutions. It was more just categorizing what you found.
Yes, and then lots of people would go from there and say, well, you need to ask 5 whys, or you need to do cause and effect, or you need to do something else to find what were these different things. Go ahead and run so where did this stuff come from? What was the history of this? And really back in this is going to seem like ancient history, good old William Haddon, back in 1963, came up with this idea of a hazard or energy in a target. And that the car was the energy, and when they crashed, that was the target, and how much energy, and what were the things between the safeguards, the barriers between, or defenses between that one car and a tree, that one car and another car, that one car and a pedestrian, whatever the accident was going to be. And then that later on in 1975 got developed by what was it called? It wasn't the Process Safety Center. It was the System Safety Center in Idaho, developed the barrier analysis model. And that's the one where they said there's a hazard, which is a form of energy, and a target, and you've got safeguards, these walls in between. And when a safeguard fails, that hazard gets one step closer to the target, right? And if all your safeguard fails, then your hazard can get through to your target and cause damage. So that's the whole, and that's back in the mid-70s, okay? That's where that comes from. Next thing you have is, and that's just an adopted model. Reason just adopted that model. Then Reason in the middle 80s, I think 87 is when he published it, came out with the GEMS model. Oh, I can't remember what GEMS stands for. Who cares? The GEMS model. And that's certainly GEMS doesn't spell slips, lapses, and mistakes, does it? And that was based on work of Donald Norman. Donald Norman was one of the original engineers who worked on the original Mac computers. And he worked on the human interface of the Mac computers. And so he came up with this idea about errors in 1980. And Reason adopted that, and also the work of Jens Rasmussen with his skill-based, rule-based, and knowledge-based decision-making model. And you put those together, and that became the slips, lapses, and mistakes. And it may not be clear how that happened, but it happened. So that became the active error part of this. And then Reason's real big, besides adopting all these things, his big contribution was coming up with this idea of latent errors. And that goes back to latent pathogens. Say it again.
You got it right.
Latent pathogens. And a latent pathogen, let's say you've got some kind of fly bit you in Africa, and it inserted a little stuff under your skin, and those pathogens went and spread throughout your body, but it didn't do anything to you right away. But the next time you experienced, I don't know, really hot temperatures, really cold
Heat
temperatures.
shock or something. A lot of stress from work.
Yeah, something like that. It could activate those latent pathogens, and all of a sudden you'd get really sick. So it lays dormant until something triggers it.
Some stress or trigger.
Something triggers it, and then all of a sudden you find out you've got it. So that was the idea behind latent pathogens. And so these latent errors were things that were built into the system, were sitting waiting there to catch you. Maybe it's a bad human factors design out here. And it makes it highly probable that you're going to grab the wrong switch. But most of the time you grab the right one, but under high stress, you might grab the wrong one, and now you've been triggered by that latent condition.
Or it could be something like you've got a bolt that wasn't properly tempered, and it's sitting in this bridge.
That's a good idea.
And over time, there's nothing happening, it goes under that extreme stress.
Maybe it's getting a lot of vibration on it, so it's getting fatigued there, and all of a sudden one day the big truck goes across and it snaps. Yep, that would be a latent condition.
That's something over time.
It's a physical condition, but...
So the purpose of that model was to help with that cognitive psychologist understand that human error.
Well, and explain it to other people, and so they'd have a basis for talking about error between each other. Well, was that a latent condition, or was that an active error? Was that a slip, or was that you could categorize these things then, and you could say, well, mainly we have slips, but occasionally we have mistakes. And maybe slips are 80% of the time. And slips are when you're doing, when you're on the Jan Rasmussen's model and you're at the skill-based level, but mistakes mainly happen when you're at the higher levels. So, you can start making and discussing these kinds of things. Okay. Lots of good stuff for cognitive engineers sitting around drinking beers.
So that helps you analyze. They were thinking about categorizing, but it really was kind of early development of some of that stuff in a way.
Yeah, and he wrote a book on it, and it got out, and people were like, oh, look, there's a way to think about this. Look, it's not just an error occurs and the accident happened. There was a whole bunch of things that set that up.
Okay, so figuring out what it set up. Now, he's quoted as saying there's no good way of classifying errors.
Yeah, he was out at the Royal College of Physicians there giving a talk.
But trying to find one that can show you how to take remedial action, that's what his goal is.
I like this. There is no one good way of classifying errors. So he's saying, hey, there's lots of ways out there.
You can classify it all day.
But you want to try to find one that shows you how to take, in other words, you want a classification system that's going to help you fix things.
Yep. So taking away from those academics.
No,
maybe not taking away from.
It's just that there can be lots of discussions, but you got to fix. In real world, you got to fix something.
Yep.
Your boss doesn't want to have a talk about the accident over a beer and do it once a week. He wants these things to stop.
They don't want to spend time writing a bunch of papers. They want to fix a problem. So at the end of the day, the model is only useful if it's driving you to actually fix the problem.
Exactly.
So this is kind of where we transition to how do we get beyond just a model that tells you how to classify?
Because by this point, I'd understood those other models. They were all understandable. I knew what they were doing. But I didn't want to... I had people who were having accidents in real-life work, in a real-life plant, and they wanted to fix things. They didn't really care about the, cognitive this and cognitive that. They wanted to say, what do we do to keep these from happening? So I wanted to be able to make this usable by people in the field so they could understand the root causes of human error. And these are root causes that they previously weren't discovering. They were saying human error was the root cause before this, right?
Yep.
Human error, well, that's it. No, what do we do with human error?
Fire the guy.
Yeah, but we're gonna torture him for a while first.
Oh, sorry, we got to retrain him a couple times.
We got to retrain him. We got to counsel him to be more careful.
Haul him out in front of everybody, put him on the mast, and embarrass him.
We got to make him give presentations to everybody else about how he screwed up and he won't ever do it again.
They got to present out their own mistake.
all those things. So, and maybe write a procedure that's extra long.
Oh gosh, the guy that made the mistake wrote the procedure? Oh,
Yeah,
no.
it could be. So the idea is, I wanted to categorize these things. First off, I wanted to categorize them so I could understand the data.
Yep.
And second off, I really realized that once you got to this level, I thought it was obvious how you could fix them then. So once you got to the root cause level, to me, it was an obvious fix at that point. Does that make sense?
Yep.
And then really, this is number 4 was number 3, but number 4 is I want to be able to collect data over time and say, hey, are we getting better? Are we getting worse? What's our top 3 things that are going wrong? Those kinds of things. I wanted to use that data.
And are those same 3 that we had last year, or we got new problems? Have we corrected some of these things?
And maybe did we get rid of some and they came back?
Yep.
Those kinds of things.
So that first step into this, then, what does that look like for your original model? Right?
Well, this is going to tell you how accidents happen, but the first step in developing this was I sat down with a whole bunch of accidents and I started saying, what were the root causes of these? And first thing I realized was it wasn't one root cause. It was usually multiple root causes or multiple things that went wrong that caused an accident. So there were multiple root causes rather than, you get the idea from the word root cause that there's just one.
There's a rootiest root cause.
I didn't find that to be true. I found that there were root causes. And the second thing is I found that there were human causes, but it wasn't the human's fault. It was the system that was helping, sort of like those latent conditions. The system was helping people make mistakes. There were systems that people didn't make mistakes in, or very, very rarely made mistakes in, and then there were systems where people frequently made mistakes, and there were human factors, reasons why some systems were more error prone and some were less error prone.
So we had to understand how the accident happened and identify
that's a different part.
Yeah.
Before you can start saying root causes, you have to know what happened before you can understand why it happened, right? And that's what this first one thing is all about: is how did the accident happen? What was the hazard? What were the targets? Usually in most good systems at most industrial facilities, there's multiple safeguards to keep that energy away from a target. And so you usually had to have several of those
failures.
Several failed barriers, several failed safeguards before you had an accident. So an incident usually was 1 or 2 or 3 of those broke, but the last one, which could be luck, didn't happen. So it was an incident rather than an accident. And you were doing incident investigation rather than accident investigation.
Now, when we think about this in the Taproot system, and we'll get into this a little bit later, we want to say, well, what happened first? So we're going to go out and find those details to identify these multiple points of failure.
We're going to want to have the whole snap chart in front of us, which lays out the timeline of what happened. And you're not trying to place blame, you're trying to collect facts.
Now that leads us to when we find these failures, we find these breaks in the system, and now we have to understand how that human error impacted that accident. So that kind of looks... Right here, we've got these different errors, and there's different ways these things can fail.
You could categorize causal factors if you wanted to, along the lines of, did it cause the hazard to grow? Did it allow a barrier to fail or safeguard to fail? Did it allow a safeguard to be missing? Did it allow the target to get too close to the hazard? Or maybe something that happened after the incident that allowed it to get worse. The incident happened, the guy got stuff splashed on him, but he didn't go to the safety shower and wash it off right away, so therefore it burned into his skin. Don't know why he wouldn't do that, but let's just say he didn't.
Now, people say at this point, we've got the problem. We found somebody made a mistake.
And in the old days, that would have been, Joe screwed up. What do?
Fire him.
Well, okay. You could
I'm going to fire him. I'm going to fire Joe.
Start off with, tell Joe to be more careful next time.
No.
Now, I remember this, what place I worked, there was a guy, they had to climb up a ladder and do this work, and he ended up, I won't go the whole story, but he fell off the ladder and broke his leg. And I remember the management argument. They were arguing about what they should do to discipline him because he'd fallen off a ladder and broke his leg. And I suggested they should break the other leg. That would really put it home to him. And when you say that, you say, well, he's already got a broken leg. Do you think maybe he doesn't want to fall off ladders in the future? He probably doesn't, right? He probably doesn't need any more enforcement. He's got a broken leg.
Yeah, cutting his pay is not going to change his opinion on falling off ladders.
No, he's going to be very cautious in the future about falling off ladders. He doesn't need it. And they didn't find that very humorous, by the way.
I don't think so.
They did not find that humorous. Sometimes my humor can get me in trouble.
Maybe.
Anyhow, go ahead.
So we understand what happened. Now we're looking at what human error impacted that accident. Now, what does that lead us to?
Hit the clicker. It leads us to a model, of course, because we're talking about models here. And this is sort of our model of a root cause, if you will, that we've had a failed safeguard. Some error, some causal factor caused that safeguard to fail, and we want to find the specific root causes and the generic root causes of that that error, that causal factor.
And we could have multiple failures, multiple failed
safeguards. This is just one. This is one. Exactly. There's usually multiples of these, which is why if there was only one root cause of this error, which there could be more than one root cause of this error, but if there was only one, there would still probably be another couple safeguards to fail, so there'd still be some more root causes.
Yep. So we could go back and look at that multiple points, and we would have, just like under that, additional causal factors and
that
multiple root causes.
The one with the 4 walls that broke, we could have 4 of those.
Yep. So you could have multiple root causes. And that's something I think really important to think about, is there's not just one causal factor.
Everybody, some people say that. Well, root cause analysis, they're looking just for the root cause. And there's no such thing. Well, yeah, there's more than one.
Now, people often get confused when we say root cause. They misconstrue it as different things. But you recognize there was kind of a need for a model to actually analyze and categorize root causes.
Okay, so if back in the day, let's say this was back in 1988, people would say, oh, root cause, what is that? And they didn't even have a very good definition of root cause. So we had to first come up with what is the definition of a root cause. And back in 85, Dave Bush and I came up with this. First off, we asked a bunch of people, and everybody had a different definition, which if you define things differently, boy, how are you going to find one that fits all these definitions? So we decided we had to find a definition that we could agree on, and we could get other people to agree on, and then we could start to come up with what are these root causes. We actually thought we already know what root causes were, but if everybody wouldn't agree on a definition, we'd never get everybody to say, yes, those are root causes. So this is the definition. The most basic cause or causes that can reasonably be identified and be identified that management has control to fix, and when fixed, will prevent or significantly reduce the likelihood or consequences of the problem's recurrence. So this is all about preventing problems.
And it's all about things that you can fix.
It is. Well, and that's where you'd get in, the management has control to fix part would cause lots of arguments. And I'd say, listen, don't worry about that. The root cause tree gives you an operational definition, so you don't have to have that argument. Things on the tree are fixable by management. And we went along with that for quite a while. But what we found was it was looking for negatives, if that makes any sense. Root causes were seen as bad. It's a root cause. It's a problem. It's something that needs to be fixed. It's
the mistake that this guy made. He should have just known this. So we
decided that wasn't good. We decided that what we really wanted people to look for was ways to improve. And so we wanted to find the good procedures, the good work direction, the good QC, the good management systems, the good training, the good communications, the good human engineering that would prevent these errors. So if you think about that down there, the latent errors, back to the model of reason, the latent errors, we wanted to have good things so that there wasn't a latent pathogen. We wanted to have good things there. And so we came up with a different definition.
And really, I think the core with this is the causes of error are the opposite of good practices.
Yeah, and before we came up with this additional definition, I used to tell people that they needed to turn the tree upside down, and then they'd see that the turning the tree upside down, you were looking for the good things, you weren't looking for the bad things.
Yep.
So we weren't looking for bad procedures, we weren't looking for bad training, we weren't looking for bad management systems. We were looking for ways to improve, which were good training, good procedures, good work direction, et cetera, et cetera.
And that kind of led you to this new definition in 2006.
So what we were having people do is a root cause was the absence of one of these best practices. And we wanted them to do was the absence of best practice or the failure to apply knowledge that would have prevented the problem or significantly reduces likelihood. Because if you can say, well, that'd prevent this problem, well, that's a root cause, but it's a positive root cause. It's something you can do to improve things.
And that kind of leads us back when we're thinking about that prior method of what do we want in a model. We want a model that's going to tell us the thing we need to do to fix the problem.
Yeah, and if you think about this is 2006 by the time we argued this one out. Think of how long it took us. So we're 18 years into this before we figured out, we ought to have a different definition, one that focuses on the positive.
The positive.
And so it wasn't exactly an instant idea.
So we've got this list, these lists of best practices. Where did they come from?
The backside of the tree.
Where did the backside of the tree come from?
Okay, so the backside of the tree were the root causes that were initially in my head. But they were in my head because I'd spent 2 years at the University of Illinois studying human factors. And so I had all this research, all these things I'd studied. And if you look at this slide here, you can see just on the procedure side, there's all these different places where good procedures have all these good practices built into them. And so what I did was I kept finding where these best practices were missing. And they were missing a lot of places. And you can talk to lots of engineers who've written procedures before who've had no training in writing procedures, no training on human engineering. And why did they write the procedure that way? Well, because it seemed like a good idea to me.
I find in most of my courses that I'm teaching where I cover the procedure section and I ask the group, who writes a procedure? Over half the group raises their hand. I say, keep your hands up. Put your hand down if you have not had previous procedure training.
And all their hands disappear.
All the hands disappear. They haven't had it, or you say leave your hand up if you've had.
Yep.
And so you find that everybody's writing procedures and maybe one person. Maybe they had something in college. If they're lucky.
Well, and that relates back to the other question I used to ask in the 5-day courses. First thing I'd ask is, have you been to a 2-day course yet? Because I just want to know how many people have been to 2 days. Second question I've asked, how many of you have had any formal human factors training?
Yep.
And I bet in 25-person courses, maybe one person would have their hand made up. So that's like 4 or 5% of the population of people coming to a course on root cause analysis have had any kind of training on human factors. And not only that, but most people who are there in that 5-day class have already been doing investigations.
Yep.
They've not been trained to do investigations. They've not been trained on human factors. But guess what they've been trying to figure out? What's the cause of human error?
Yep. So
they don't have all this background. They don't have all this research, and they're looking for something that's invisible to them.
Now, was the tree perfected day one?
Oh, as the first time I mentioned tree, there it was. It popped up out of the ground. No, it took a lot of years. So the first book we wrote was in '88, and it was a little book. The second book we wrote was in '91. We revised, that was the first taproot manual. Revised it in '92. We revised that again in '95 or '96. And then, and the tree got revised along with all these then it was 2000, then it was 2008, and the last one, this last version of thing, we started in 2015 and we ended in,
Well, the last book was 2020.
so 5 years
the
to write
Stop
the 10 books.
Now that the last tree revision was 2015.
What I like to tell people is every time I write a book, it takes a year of my life.
So we get this thing's evolving, not just your knowledge evolved, but also we've been having user inputs. We get advisory board advice from our users.
Sure.
And so it's really grown and adapted over the years.
Exactly. And we have had lots of good ideas from other people.
Yep.
And testing and revisions.
Now, categorization
More so from the early days than the later days.
True. It hasn't been big changes lately.
Minuscule changes lately.
Now, you had the tree, you had the categorized list, the backside of the tree.
I had actually a checklist to start with. I had a checklist of things, and I was just playing with this checklist and saying that incident had this one, that incident had this one, and I didn't even understand causal factors when I first started out. I was looking for root causes of the incident, and probably about a year into this, I discovered it's not root causes of an incident, it's root causes of a causal factor. And that may not be, we don't have any examples of that here, but it's like the incident's the last thing that happens. The causal factors allowed that progression to occur or started that progression.
Just like those failed barriers.
Just like that. So I started out thinking, we got a few causes here. I then started thinking, I actually went up and talked to a guy up at DuPont headquarters, and I was at the time working for DuPont. And this guy showed me he was trying to make a tree of root causes. And I didn't like his root causes at all. Didn't think they were very good at all. But I liked that format of a tree branching out. I thought, this could fit into that. We could make this work. So I started playing with that branching thing. And so our first tree had branches in it, but we didn't have what we now have, the 15 questions. And so we inserted this other part that guides you to where you need to go on the back side of the tree to analyze. It's sort of like a troubleshooting checklist for human performance, and it guides you to what categories you need to go on the back side of the tree. And my problem was I couldn't see that was necessary. Linda Unger really sprung that whole idea and got that going, and she could see that it was necessary because I just thought, well, it's obvious which one you go to, but it wasn't obvious to everybody.
Yep.
And the next thing we had, and this is sort of actually before the 15 questions, was the definitions in the dictionary. We'd start using the tree and we'd start having big arguments over what do those words mean. And so finally we started writing down what definitions for these words so we wouldn't have to repeat these arguments over and over again. We'd have it written down on a piece of paper, and that piece of paper eventually became a small book that were the definitions of each of the categories of each of the leaves, I guess, on the tree, each of the root causes and near root causes and basic cause categories. And then we sort of figured out, we wrote them as a form of a question, and if you got a yes to this question, you circled that category. Well, we finally have now developed a pretty good set of all-inclusive questions for everything on the tree, where if you go through and ask these questions, you get a yes, you know where you go.
Now, I think this is an important thing because the idea that you could have just trained everybody, you could just train everyone on all these categories and root causes, and that would solve the problem.
Yeah.
I think some people believe that you could just turn everyone into human performance experts.
Okay. So let me fess up here. I occasionally would be arguing on one side of a definition and find myself on a different day arguing on a different side of the definition. So we had to write these to be consistent. It not only was so you could be a human factors expert, but it was so you could use these categories consistently and not change the definition over time, which was really, people are really flexible, and the English language is extremely flexible. And sometimes you'd want to bend a category a little bit so something would fit into it because you didn't think of all the categories to start with. And, well, that one needs to stretch some. But really what you needed was a different category. And you needed a different definition for that.
So I think the idea that I think something that was really revolutionary with this process is not just the categorization, but the guidance for the categorization, because now you don't have to be a PhD to talk about error and figure out and drive down to it.
Although I will say that after you use this for a period of time, you will refer to the dictionary less and less because you'll have more of these definitions memorized in your head.
But I think a lot of that with the new people, because, if you didn't spend 2 years of just nothing but, 80-hour weeks pouring through human performance research,
Right.
It can be daunting. Human factors is a deep ocean.
Yeah.
And a lot of times in a short course or in, these short meetings that people have, you're just visiting the beach.
That's true.
You're not getting in there. You're not.
I like that. Visiting the beach.
So I think of by giving that guidance, you've done the exploration, you've gathered this detail, and now somebody's got a map. They've got a map that they can follow behind.
A chart.
A chart.
So they can go out on the ocean of human factors.
Maybe it's a treasure map. I don't know.
Oh, who knows?
But I think that's really important with that guidance. It's not just here's a list. It's not just here's my knowledge as an expert. But this is a guided system that's going to get people down to those.
Well,
root cause
I think
levels.
it's very important. Yeah.
So that kind of put it all together there with Taproot. Kind of walk through that Taproot, putting it all together.
Why don't you hit the button for me? We'll go through what it says. So we've got a model, right? We've already talked about the model. We've got the root cause tree. Hit the button again. There comes the root cause tree in, and this goes all the way back to 1985. Although really the first commercial version we put out was 1988, and there's been a lot of revisions since then. And that's the root cause tree. We took that root cause tree, hit the button again, and built that into a systematic process that isn't just go find root causes. It's a whole investigation process, and we built that into a system. We wrote the first root cause tree book, which was the whole take the tree and
Big
write
giant manual.
Well, no, it was a little tiny book to start with, right? Then in 1991 we did the big giant manual, but it was even pretty thin back in 1991 because we had about we wrote that first one in about 3 months. So you can't make the heavy paper weigh too much if you only got 3 months to write. And then we decided right away back in 1991 we decided we wanted software. And so we started working on software, and that came out, the first version of it, in 1994. The first version was actually on a Mac Plus computer, which you probably don't remember those days. And it had a inkjet printer that you could put the Mac Plus computer and the inkjet printer in a backpack and wear it on your back and take it off to go do an investigation.
Oh, the 90s.
And so that was the first software. We got a software patent issued in 2002. That took about 5 years to get the patent issued. After that, I guess the next thing we started working on was in about 1997. We had people say things like, well, this doesn't work for equipment. And I found out that the reason they were saying that was because they weren't able to do equipment troubleshooting. So if you don't know why the equipment, or if you don't know how the equipment broke, it's hard to figure out why the equipment broke. And so we came up with a troubleshooting tool based on Heinz Block's troubleshooting techniques called Equifactor. And we built a course for that, and we built it into the software. And it's got troubleshooting tables built into the software so you can do good equipment troubleshooting, and then the root cause analysis follows that. And finally, I don't want to say finally because we're still coming up with good ideas, but the next big thing that came up was the corrective action helper. And that corrective action helper was originally put in as a module in the software. And 5 years later, they convinced me to make that a book so we could hand it out to everybody in the course. And it became the Corrective Action Helper Guide. And so that's the sort of the history in big chunks of the development of the Taproot system.
Now that basic process, that model really breaks into this 7 step.
This 2 pieces here came out in
16, I believe.
15. It had to be 15.
Yeah, it had to be 15.
It had to be before 15. It was probably about 2014, and we decided we'd always had the right side, which is the 7-step process. the Taproot 7-step major investigation process. It was just called the 7-step process to start with. And every investigation, and we just knew if it was a simple incident, you shortcut some of these steps. They were really easy to do. But I had people keep complaining about, oh, it's too hard. There's too many steps. What's the minimum you have to do? And of course, because everybody complained, I invented spin a cause. And I'd say, here, take this and spin it if you want the minimum you have to do. And they'd spin it and it'd tell them an answer, right? And it was a good joke, but it really didn't satisfy people. So about 2015-ish, we said, well, we need a simpler process. In the simple process, we start out finding out what happens to draw a snap chart. And you look at that snap chart and you say, hey, is there really anything to learn in here? And if you say, hey, there's nothing more to learn, you stop the investigation, you don't waste your time, and you just stop.
Because things that are
document what you got and go on.
Because things that are really low risk, do you really want to spend
if the
people's
light
time?
bulb burned out, am I going to really spend a lot of time doing a root cause analysis on why did that light bulb burn out? And the answer is no. Now, that's a pretty ridiculous example, but you wouldn't believe paper cuts, how much time people waste on those
Just
kind of
writing
incidents.
up paper cuts. Yeah.
Yep. So then if it is something you want to have, you want to do some analysis on, we even make that easier, if you will, by quickly finding the causal factors, using the tree to identify the root causes, but we don't do generic cause analysis, which you find over there at step 5 on the high impact one. But over here, we skip that. We say, hey, if it's a simple incident, if it's not that big a deal,
It's optional.
You can do it if you want to, but nah, you probably don't. And then you develop your corrective actions, which are just coming out of the corrective action helper. You just do a few simple ones out of the corrective action helper, and you're done. And that's a simple incident as compared to all the things you need to do in the 7-step process.
So that process, that model, finding out the what happened, identifying those mistakes, errors, and failures, those causal factors that led to the incident, identifying those most likely multiple missing best practices that would have prevented those mistakes.
Right.
And then
Or reduce the likelihood.
And then developing corrective actions to fill in those gaps that we've identified, fill in those gaps of knowledge. That's the model of when we're really looking at understanding human performance and understanding what we need to do better.
That's our model.
That's our model. I think it's the model.
Okay.
It's our model for it. And it's not blame-oriented anymore.
No, and it is an understanding model, and it's an understanding with the purpose of developing corrective actions.
Yeah. Because it's not just, we don't want to just put people in a room and decide on things to fix. We want to have a process.
It's not brainstorming.
It's not brainstorming. We want to have a process that's guiding people, that's giving them support and giving them ideas. Because if we just put people in a room, well, yeah, they'll probably generate a couple good ideas because they know, people are smart, right? They know lots of good things. They can come up with ways to fix problems. But their knowledge is limited because they haven't had that human factors training.
1 out of 25 has probably had any human factors training, and that any might be very minimal, or it might have been they went to a 5-day course someplace or whatever, and they've had no more besides that, and therefore it isn't giving them a broad, expansive view of human factors, and they aren't, certified professional ergonomists or human factors experts, and they just don't know what they don't know.
Yeah, so the idea that we're just going to solve our problems with brainstorming
isn't going to work.
Happen. You've got to get something that's got expert system that's going to guide you through this human performance stuff.
There's another thing to point out on this, and I think this is a little bit separate from this talk, but notice there's no develop a hypothesis here. Right. Everybody says, oh, you need to use a scientific method, you need to develop a hypothesis. Well, developing a hypothesis has all its own problems. The scientific method has all its own problems, and it has to do with people wanting to verify their hypothesis. After they make a hypothesis, their brain starts to say, it's correct, I'm going to find what proves it.
Find my data, the truth in the data will
and your brain starts then ignoring if it doesn't fit, goes right on by. And you start seeing what you want to see.
Yep.
And we don't start out that way. We start out saying what happened. and you get a good, complete understanding of what happened before you ever start trying to think of why it happened. Yeah. So you don't have to make a hypothesis, you know from the evidence what happened. Rare cases you don't. Rare cases you might not know what happened, but that's pretty rare.
Yeah. Now, where do we use this?
Everywhere.
Everywhere.
Everywhere. I would say this list up here doesn't have everything on it. It doesn't have cost overruns. It doesn't have schedule slippage. So any place you got people making mistakes or causing things not to go well, and notice that's the negative view things, anywhere where people don't prevent negative things from happening, maybe that's slightly more positive, anywhere where things go wrong and you want to find out why it happened and find root causes and fix them so that it doesn't happen again, that's where you should be using Taproot.
One of the customers, and I won't say their name, but I'll think about something that was always an interesting one to hear that they were using Taproot. They were a online gambling and lottery.
I've never heard of that one before.
Online gambling and lottery.
That sounds pretty different.
They came to a course after they had this major incident where they gave a bunch of people their money back when they shouldn't have.
Oh my goodness.
And they were applying...
Lucky gamblers.
Lucky gamblers. And they were applying Taproot and thinking about the human form. And you'd think with a big old online software system, oh, that's a bug in the system. That's a system problem or a mechanical failure, right? That doesn't have anything to do with human performance. But when you look back into those mistakes, you find... there was someone who wrote that software, someone who designed that system, someone who was responsible for these checks or these new...
or didn't do them.
Or these new analyses when we input new lines of code in, and how is it going to affect these other systems? And so there's gaps in those human performance elements where people make mistakes, even in something like online software.
Well, if only I knew which one that one was, I could have got in line for some money,
Wish I knew
right?
that day, right?
Yeah.
So anywhere people are making mistakes, you can take this process and think about how do we improve our systems and make them better for our people.
And you start to talk about weird cases. Another one that was really strange was there was a regulatory agency that looked at abuse cases in mental institutions. And they were using Taproot to investigate abuse cases in mental institutions. And I thought that was a pretty strange one too. I had never thought about it. They had the one case where this guy was starting fights, and they eventually figured out by using Taproot, mainly the snap chart, that he was starting fights because he wanted to sleep during the day, and they wouldn't let him sleep during the day. But when he got in a fight, they'd restrain him, which meant tying him down on a bed, and he could go to sleep. So you just never know.
So that's one ROI that we've heard.
Yes.
What are some other ROIs?
Well, there's the more standard things you can think about. Lost time injury rates being reduced, reducing your workers' compensation costs. One of my favorites there is the one that says chemical plant. I remember when Jeremy came to our course, and there was a series of these things he went to, and he finally ended up in the summit. And I said, "What are you guys doing here?" And he told me the story how their plant was going to be shut down, and how they came to a Taproot course and they went back and they found that every shift was operating the plant by their quote-unquote procedure, which wasn't the same as the written procedure. And so that at every shift, when that shift ended, the next shift would come on and they'd have to go, "You're doing this wrong. I want to do it my way." And they'd change all the settings and things, and they'd have about 15 minutes to a half an hour or more of waste product they'd have to dump while they got to run the plant to where it was running in the way they ran it. And so every day they were an hour, 2 hours worth of dumping product. And when you start thinking of 2 hours a day of dumping product, what kind of percent of your volume are you losing? They got rid of that, and all of a sudden they went from a money-losing facility to a money-making facility. And he said, once we got rid of those, every shift there was an upset. Then we could start looking at the fewer remaining upsets that we had, find the root causes for them and fix them. And he said pretty soon we had a plant that ran really smoothly. And that was the $40 million in 2 years, $20 million the first 2 years of savings they recouped by fixing things that worked in the plant. And they ended up getting an award, and they got flown up to New York to have, they were down in Texas, they got flown up to New York to have dinner with the CEO of the company. And they thought that was pretty cool because not just any plane, they had the corporate jet come and get them. And most likely operators and engineers don't fly too often on the corporate jet.
So 20 million in 2 years is pretty good. But I'll tell you, my favorite stories that I hear on this, we hear them a lot at the Taproot Summit because we got people sharing their best practice. My favorite stories is always the we don't kill people anymore.
Oh, those are always good ones.
Because, I think it was just last year we had somebody reporting out in the summit. They showed a graph, and they had the fatalities each year.
Yeah.
And they had 5 fatalities, and they had the going back, they'd have 5 fatalities every year.
Yeah.
And then Taproot implementation, and I think it was 2 years after that, they were down to 0 fatalities.
And just a flat line of 0 after that.
And that's the things that I always think about is the we don't kill people anymore, and the people that get to go home at the end of the day.
So the Skyline Mines was the one that I remember because this guy called me right before Christmas to tell me about they'd had this fatal car accident where a drunk driver came over and struck their employee's car head on the way to go to training, and he couldn't find a root cause. And I eventually agreed with him that there was nothing that company could have done. They could have done. It was all on the drunk driver. But he told me that they hadn't had any fatalities. They used to kill 1, 2, 3 people a year, and they hadn't had any fatalities for like 5 years. And I started thinking about, well, that's like 10 people going home for Christmas that wouldn't have otherwise. And that starts bringing it home to you that there's people and there's families and there's this impact of this injury or fatality to this person, and they're being prevented. And just like you said, at the summit every year, somebody's telling me about that.
So if anybody wants to learn more, the best way to get out to us is going to be to go into the website, taproot.com, and emailing info@taproot. If you've got
you can just use the contact us button on the website.
That's
too.
right on the contact. It's going to take you right to info@taproot.
Right.
And that's if you're wanting to implement Taproot, wanting to learn more about this model, that's where you want to go to.
And have a look at our courses. If you want to learn it the fastest and don't want to commit too much time, the 2-day or the 3-day virtual course. But if you're serious about investigating major accidents and really understanding human performance better, I suggest you at least go to a 5-day course. And if you want to know more about stopping human errors, there's a Stopping Human Error course coming up
May 2nd.
Yeah, May 2nd and 3rd. It's not very far away. It's like a month from now.
Yeah, they might even have to, whoever's watching this, you'll just have to go to our website and see when we're doing the next one.
Yeah, that's right, because we're talking about this now, but in real time, you may see this 6 months from now.
Yep.
It's past May 2nd, and you want to see when the next one is, and that'll be on our website.
Yep.
And then, of course, there's the summit. We didn't mention that.
Yep. Well, we did mention it. You should come and hear the best practices. You should come learn more. If you want to learn more, again, check out the link in the below. That's website to taproot.com/summit for the summit, or just taproot.com in general. If you want to think about what is your best practice for human error, comment down below.
Yeah, let us know. What's your model?
Comment, subscribe, and all that fun stuff.
What's your model?
All right. Well, we'll see you guys again in the next Taproot TV.
Bye.